Very good afternoon to one and all. On the behalf of IT Department, SKN SITS Lonoda, I am Aditi Patil, today's session coordinator. It's my great pleasure to welcome you all for the Virtual Faculty Development Program on Day 3, NLP. Respected Principal, Dr. M.S. Rokle sir, respected HOD of IT Department, Dr. Priyanka Halle ma'am, respected HOD of Computer Department, Dr. Sarang Patil sir, respected HOD of Mechanical Department, Professor N.K. Gaude sir, respected HOD of Engineering Science Department, Professor G.V. Khandekar sir, all dear participants, once again, I extend my warm welcome to all. Some instruction for all dear participants. Please mute your mic and video during the session. Feedback from attendance link will be shared to you in chat box at the end of session. The last 10 minutes of session will be provided for discussion. You can ask your queries. Now let's start with today's session on NLP. We are honored to have resource person, Dr. Praveen Latne, sir, Assistant Professor, IT Department, SIT, Lonavala. We are very happy to welcome you, sir. Now, I would like to introduce our resource person, Dr. Praveen Latne, sir, has worked as an assistant professor in IT Department, SIT, Lonavala. He has done his PhD in electronics and telecommunication. He has total 25 years of experience. His research interests include embedded system, wireless sensor network, control and automation, Internet of Things, data science, and antenna design. He has authored more than 37 articles in peer-reviewed journals, international conferences, and books. He has 2 patents in his credit. He is reviewer for IJST, IJEC, AIC. He received Best Teacher Award in academic year 22-23. His active participation in academic and research can be seen by the international conference, workshop, seminar conducted by him in the past and expert talk delivered by him. Thank you. Now I'd like to request Dr. Latne sir to start today's session.
Thank you. Madam, is it visible?
Yes, sir.
Okay.
Yes, sir.
Okay. Good afternoon to all. Respected Dr. M.S. Rokle sir, Head of the Department, Dr. Priyanka Halle madam, and all my dear faculty members. Today, I'm going to deliver a session on natural language processing, concept, model, and few applications related to it. Before starting the subject, we should understand what is the natural language processing. So in short, basically, it is a process of analysis of input provided in human language and conversion of that input into a useful representation. Basically, natural language processing is having 2 primary concerns. Primarily, it is used to convert the given information in useful and interesting task with human language. Here, the human language are any language, not only limited up to English, Hindi, or Marathi. You can have a French or Japanese language as well. A second concern about natural language processing is to help us to better understand the human language, because in a given language there are so many ambiguities. In given language, the same word are having multiple meanings. So which is the correct meaning that should be understood by your machine? What do you call it? The understanding of language. Uh, Natural language processing, basically
Lathi
it is
sir.
a hottest topic.
Sir,
Yes, am I audible?
hello.
Hello.
Yes sir. Sir, please 2 मिनट. Sir, actually सुभाष पाटिल सर का mic unmute है. Sir, 2 मिनट रुकिएगा. सुभाष पाटिल sir. Subhash Patil sir, kindly mute your mic. Yes, sir. You can continue. Hello.
Shall I continue?
Hello. Yeah.
Shall I continue? So basically, natural
Yes, sir.
language processing is the hottest topic in field of data science, and companies are putting tons of money in research of this particular subject. So basically, most of the company or everyone is interested in doing some application and making career around this particular subject, and every business want their contribution, their business to be run through this natural language processing concept. In a few years of time span only, that natural language processing has evolved into something the powerful and impactful, which we cannot imagine. So basically, to understand this particular topic, we should understand first few applications of this natural language processing. So we'll discuss that application in short. First application is, all you are familiar with this particular autocorrect and auto completion. All of you are experience this type of experience while searching on Google. You start typing, though it is the correct word or it is a wrong word, it will help you, assist you to correct your language or correct your word and complete your sentence. So this is basically on the back end. Google has played one algorithm which deals with this particular issue. Second application is a language translator. So basically, you can translate your given language into any given language. Here, the hurdle between language translation is the grammar or ambiguity in a given word. So that was also dealt by natural language processing. We'll have one small project of language translation at the end. Then is a social media monitoring. Basically, companies who are new in the market, they want to make a survey of their product and they want to see what is the review of the product. And depends on the survey, depends on the feedback coming from the customer. They just analyze the product and find whether there is any issue with the product, and they can improve their product in future as well. Very interesting application of this natural language processing is a chatbot, which is basically a rule-based chatbot is also possible, or a machine learning chatbot is also possible, which will help a human to solve or give the questions asked by the customer. So that we have a short demo of this chatbot at the end of the session as well. The next application is the survey analysis. So again, if I take example of any organization and they want to just analyze what is going on in their organization. So by taking some surveys from the customer, from the employees, from the student, you can visualize that data and get the correct feedback of the student or employee or the customer. What do you call it? The survey analysis. Then a targeted advertisement. I think all of you have experienced one experience when you are searching something. After a few minutes only or few hour only, you start getting same advertisement. Suppose you are searching shoes, you want to purchase it. So after few time, you got the different advertisement related to the shoes, and this was what we call as the learning of your behavior. In short, we call it as a machine learning. So it start giving you the targeted advertisement. So every customer is having different advertisement. That was the thing. Then hiring and recruitment process. All of you know nowadays, for a few posts there are thousands, hundreds of CVs. There are thousands or hundreds of CVs coming to the HR, and HR is in not position to get the scrutinized given CV or applications. So what we can do here, we'll have some algorithm which is a natural language based one, and we'll just see search some important keywords which we are interested, and immediately we can sort out our CVs, and that will help in hiring and recruitment process. Then is a very interesting, you all are aware of this voice assistance. So this is Google Assistance as well, you are aware. This was one example of Alexa. So Alexa will listen to your speech and it will recognize it and just convert that into a respective command. For example, if I say, Alexa, please turn on the tube. So it will do respective job and just send one command to the relay, which will turn on your tube and so on. So it was just a conversion of speech into a command. There is a grammar checker. So all we have observed, Grammarly is one popular software which is used in this grammar checking, which will help you to get your correct grammar. Then is email filtering. Again, you have you will observe in your email box there are three columns. One is a primary, one is a secondary, and then is a promotional emails. So automatically Google will on the back end will sort out primary message which are important to you, then some social messages coming from either Facebook or either Instagram and so on, and some promotional mails which are coming from different companies. They are automatically separating you, and they are saving your primary box by overflowing. So basically, these are a few examples. Now coming to our topic. The formal natural language, the forms of natural language, where you are having inputs and outputs. The inputs can be in the form of text or speech, or again output can be in the form of either speech, text or speech. So mostly we are dealing with the text one in this discussion, not the speech, because that was again separate topic. So before processing any written text, we should know some knowledge about lexical, syntactic, semantic knowledge about the language. Then you should know discourse information, real world knowledge. And here is one example of how language could be understood by a machine. There is one sentence, literally your Facebook Messenger app is useless. You only want it to increase profit. Please fix yourself. It's a sad at the rate Facebook. That was one message written by any customer. So from this sentence, we have some understanding. For example, emotions. So emotions is a frustrated, which we can understand. The tone of this particular sentence is a negative, which is a subjective. The uh, organization which is used to whom we are going to address is a Facebook, and we are talking about a product which is a messenger app, and the adjective which is used in this particular sentences are useless and sad. And very important, language which is English, and it is not a formal English, it is an informal English language. So this is how you can understand this sentence. Now it's a job of you to make understand your machine all this parameter. So if I use both natural language processing and natural language understanding to sense the unconstructed or unstructured data, but there are difference between both concept, natural language processing and natural language understanding. So basically, natural language processing will work on language, and it facilitates natural back and forth communication between computers and humans. But in case of natural language understanding, it will just focus on the machine's ability to understand the language. Okay, and then you can understand and analyze and get the meaning. For example, Alexa should understand how to turn an off tube, like that. If I take one example of question answer, I have one questions. What is the weather like tomorrow? So if I want to get the meaning or to understand this sentence, I have to separate each and every word. So for example, in NLP tools, we have to separate the topic. So topic of this particular sentence is a weather, and what is the time or date which we are dealing with is a tomorrow. So basically from this, we can understand actually the question is asked about the weather and the information is asked from about the tomorrow. So this was the things you should understand, and your machine will now start collecting data from different natural language documents, online news reports, or collect web pages and reference texts, and pop up it to the user about the weather on tomorrow. Now, if I want to understand any language, basically one hurdle comes in picture is a ambiguity. Your given language is always ambiguity, because we are having for a single word multiple meanings that we'll see afterward. So only first ambiguity is how to represent meaning and which structure map to which meaning structure. These are the few ambiguities we are facing while dealing with understanding of your language. One input can have many different things. Ambiguity can be at different level. That levels can be a lexical ambiguity, a word level ambiguity, we can say. Syntactic ambiguity, a different way to pass the given sentence. Interpreting partial information, how to interact with the pronunciation. And then is the contextual information, context of the sentence. What is the context of a previous sentence with the next sentence that we have to understand. So if I take one example, for example, there is an exhibition of bank on the bank of river. If I see this sentence carefully, there is one word bank coming two times, but same word is having different meaning. Here, first time the bank on exhibition of bank, matlab, there is some financial companies, and bank of river, it means shore, seashore or any shore of your river. So here the bank word is having two different meaning at different position. So this was an ambiguity, and machine has to deal with this ambiguity. What is the meaning of bank first time, and what is the meaning of bank in a second time? These are the some points you should understand about the language. We call it as a knowledge of language. First one is a phonology, then morphology, then lexical, then syntactic, then semantic, then discourse, and pragmatic. Let us understand it. Phonology that deals with how words are related to the sound that realize them. Morphology that concern how words are constructed from a more basic meaning, what we call as the root words. And normally the root words are converted in a tense, present tense, past tense, plural, multiples, and so on. So that we have to understand. Then syntax that concern how can be put together to form correct sentence and determine whether it is structure, it follows structure rule or not. Then is the semantic concern, what words mean and how this meaning combines in a sentence that you have to understand. Then pragmatic means that comes with concern with how sentences are used in different situations and how its use affects the interpretation of the sentence. Then discourse that concern how immediately preceding sentence, next sentence is affected by the previous sentence. and very important is a word knowledge. You should have a good dictionary, word dictionary with you, word knowledge, so that you can interpret your meaning correctly. Now, coming to the basic part of the elements of the simple phrase. Phrase means a sentence. The sentence is a group of words, and that words can be elements of the or parts of the speech, and these elements can be noun, can be pronoun, can be verb, adjective, adverb, preposition, condition, interjection. So let us understand what these parts of speech in short. Uh, Suppose we have 5 types of phrases. In first phrase, like a noun phrase, we are going to deal with noun phrase which is built around a single noun. For example, a vase of rose stood on the table. So basically that sentence is talking about a noun which is present in the sentence, which is a rose. She was reading a book about the emanations of women. So in this particular sentence, it is the sentence is talking about the woman. So woman is a single noun in this particular phrase. Then verb phrase is basically deal with verb part of the clause. She had been living in London. That was example. So we are talking about verb living surrounded by some supporting words. I will be going to college next year. So going is a verb, and there are will be the supporting word which are going to complete this sentence. So we have verb phrase like this. We have adjective phrase as well. So adjective phrase is built around an adjective. For example, he is managed a very interesting life. So basically interesting, that was an adjective supported by very. A lot of kids are really knee on football. So basically we are talking about adjective which is a football, and we are having some supportive word to complete the adjective phrase. Then it's adverbial phrase. And adverbial phrase is built around the adverb by adding words before and after. For example, the economy recovered very slowly. So basically slowly is adverb, and it was supported by a very, which gives the speed of the economy. And another example, they wanted to leave the country as fast as possible. So here possible is a adverb, and the process is fast, that was supported by example of as fast as. And last is a prepositional phrases. Basically, prepositional phrases build around a preposition which gives information about time, location, position, or condition. For example, he is sleeping on the carpet. He always speak in a loud voice. So on, in, these are the some prepositional phrases which talk about either time, location, position, or condition. Okay. Now coming to the next part of POS, part of speech tagging. To remove the ambiguity in a given word, you need to separate out the sentence in a single word, and you should tag each and every word by some POS or part of say speech tagging. Each word has a part of speech tag to describe its category. In short, we are going to divide your whole sentence in a categories, which are having 2 categories: open class and closed class. In open class, we can cover noun, verb, adjective, and adverb. And in closed class, we have preposition, determiner, conjunction, pronouncer, participle. And that was the job of our natural language processing, to divide your given information into different tag. So POS tagger try to find POS tag for the given word. That was the task of this POS tagging. Uh, we have, for example, a word duck, which is basically we are not going to understand whether it is a verb or it is a noun. Okay, so basically to understand the meaning of this duck, if I use single as a duck, that become verb. But if I use duck in a sentence, for example, duck is delicious for dinner, then duck become noun. Okay, so that your machine should understand what is the meaning of duck, where it is used, how it is used, whether it is single use or it is used in a sentence, and that job has to complete by the natural language processing so that you can avoid ambiguity in a given sentence. These are some tags, dictionary available. CC stand for, these are shortcuts, abbreviation, CC, CD, DT, EX, FX, FWIN, and so on. So there are so many tags available. You can tag each and every word specifically. So if I take one example for tagging, there is one sentence: sea sells seashell on the seashore. So basically, we have uh, first word. If I separate out this word, sea separate, shell separate, seashell separate, on separate, the separate, and shore, seashore separate. So we can tag each and every word. So here, sea is a prepositional pronoun. Then verb, we have sells, which is a present tense with third positioner singular. Then seashell is a noun plural. Then in is a prepositional or subordinate conjunction. And determiner is the. And lastly is a noun singular, is a seashore, NN. So these were the tags given by your machine learning or natural language processing algorithms to each and every word. Now it's good to understand the sentence meaning. Now there will be less ambiguity in a given sentence. So it is not always true key by giving tags you can avoid ambiguity. If it is not possible to cover ambiguity in this level, you should pass on this ambiguity to the next level as well, so that you can work on this ambiguity in next level as well. That we'll see here. So let's take one example. I made her duck. That was one sentence. So if I see this sentence carefully, I'm not able to understand what exactly the sentence is talking about. How many different interpretation does this sentence have? What are the reasons for the ambiguity? What are the categories of knowledge of the language? How can each ambiguous piece be resolved? Does speech input makes the sentence even more ambiguous? That questions can be answered here in natural language processing. So if I say this example, I made her duck, the meanings of this particular sentence can be like this: I cooked duck for her. I cooked duck belonging to her. I created a toy duck which she owns. I caused her to quickly lower down head or body. I used magic and turned her into a duck. So these are the 5 possible meanings of the given sentence. So definitely we as a human are that much confused. So you can imagine how machine is also confused. So we have to take care of this confusion by machine. So if I see duck, basically it is having morphological or syntactically ambiguous, because we are not in position to understand whether duck is noun or verb. If it is used single, it become noun. If it is used in a sentence, it become verb. We have a syntactic ambiguity for a word her, and semantic and syntactic ambiguity with the word make, because make is a root word of made, because made is a past tense of the make. So basically root word is a make, and make can be cook or can be create. So again, there is an ambiguity in a given word. So machine has to be trained that much, and so that it should be it will avoid this ambiguity. Now, how to resolve this ambiguity? So there are some solutions, not all are in picture. For example, we can go for POS tagging, part of speech tagging, which will decide whether duck is verb or noun. Then word sense disambiguity decides whether make is create or cook. And along with this, we have lexical disambiguity, which will resolve the part of speech and word sense ambiguity. It means if it is not possible to cover ambiguity in first 2 steps, you can pass on this ambiguity to the next stage and that is a lexical analysis. And here, duck is an example of syntactic ambiguity and can be addressed by probabilistic parsing, which is in a syntactic ambiguity. So these are the some points can be help you to solve the ambiguity. We'll see that afterward. Uh, I have a parsing of the given sentence. I made her duck. Parsing, it means we are giving hierarchy to the given word. This is actually one steps used in ambiguity resolution. First step is to give keywords tagging, and second one is a parsing. So before giving keywords tagging, you should parse your given sentence. You have to divide your sentence and then give keywords tagging. So if I have word, I made her duck. So in this case, I is a prepositional pronoun, and we have a next verb phrase, made her duck. Then made is a verb which is a past tense. It is not a present tense, is a past tense. Then her is a prepositional uh, phrase, and duck is a singular noun. So basically this complete verb phrase, made her duck, is actually again sub part of verb, then prepositional phrase, and noun or singular noun. This can be again subdivided like this. You can have noun phrase, her duck, will be again subdivided into determiner and single noun like this. Now it is the scene where you can now remove the ambiguity from the given sentence. So phrasing or parsing will help you to resolve this ambiguity. Now coming to the steps of NLP, it starts with lexical analysis, then syntactic analysis, then semantic analysis, then pragmatic analysis, and finally you will get discourse interrogation. Now let us see these steps one by one. First one is a lexical analysis. The purpose of this lexical analysis process is to determine meaning of individual word. So for that purpose, you should have a knowledge of word. In short, you should have a dictionary of the word with you, because dictionary word of English is different. Dictionary of Marathi is different. Dictionary of Hindi is different. French is different. Japanese is different. German is different, because we have to deal with every language. So we can have the ambiguity at word level. We call it as a lexical ambiguity. And word may have several meaning. That was the ambiguity over here. And how to solve this ambiguity? We can solve this ambiguity by giving POS tag. And if it is not possible, you can pass on this ambiguity to the other level. Then coming to the syntactic analysis, here we are going to parse the given sentence, which is going to convert a flat input sentence into hierarchical structure that we are right now seeing, that corresponds to the units of meaning in the sentence. So basically, there are two main critical approach of this syntactic analysis. One is a grammar, and second is a parsing. A declarative representation of describing the sentence or structure. We call it as a grammar. And if I want to hierarchical representation of sentence, we can go for parsing. So contextual free grammar, these are the center of our main concern for parsing mechanism. Then coming to the semantic analysis, assigning meaning to the structure created by syntactic analysis. In previous analysis, we have analyzed some meaning. So it is the duty of semantic analysis to assign some meaning. We have to map given word and structure to particular domain constitute of our knowledge of word, that dictionary with us. So for example, if I have one sentence, I robbed the bank. So bank is a river bank or financial institute that we are not in position to understand. So we have to decide the critical approach, how to resolve this ambiguity in semantic analysis. And then very important is the discourse, as we have already discussed. The discourse are the collection of coherent sentence, means we have to find out the meaning from the previous sentence as well. If it is not possible to understand from the given sentence, you can take a reference of either previous or next sentence. So if I have an example, Mary bought a book for Kelly. She didn't like it. So if I read this sentence carefully in a second sentence, you are not in position to understand what is meaning of she and what is meaning of it. So basically, she is referred to Mary or Kelly. It is not understood. That was one ambiguity, and it refers to what, whether it is book or any other thing. So that these are the ambiguities provided over here. So discourse structure that depends on the application. That can be monologues, that can be dialogues, or that can be a human-computer interaction that will be used to resolve your ambiguity. So we have to take previous sentence reference to understand the current sentence. That was the thing about in discourse analysis. Now coming to the some hands-on of this particular topic. So I have some pre-processing techniques in Python. So let us understand first what is a pre-processing in natural language processing. At last, you can see there is a machine learning model that job start. But before that, you should provide some clean text to the machine learning model. And it is not easy to get the clean text from the raw text. Because if I see in data science, the data is in the form of raw data. The raw data can be structured data, it can be unstructured data. Normally, CSV file or Excel file are treated as a structured data, but I have other data as well from coming from different sources. That can be audio file, that can be video file, that can be PDF, that can be image. So we have to convert that into a structured format, and then again we have to clean it, because it is not only thing is that if you convert data which is unstructured into a structured, you'll get your clean text. There are so many issues with structured data as well. For example, missing cells. That was a very big issue we are dealing with data science database. So few of the machine learning, pre-processing techniques we are going to study over here. Let us understand tokenization, then cleaning, then POS tagging, then stop-word removal, and lemmatization. Then only you will get your clean text, and then you can pass on this given information for the machine learning model. So let us understand this one by one with the Python language. So these are some types of data processing which consist of cleaning, tokenization, POS tagging, stop-word removal, stemming, and lemmatization. For that purpose, there is one library which will help to you is NLTK. The NLTK stand for Natural Language Toolkit. So in a command prompt, you can install this particular library by a command pip install NLTK, and that will be installed automatically in admin version. After that, you should import NLTK, and then you have to download PUMKT, which will allow you to collect all the packages related to NLTK. So this was the screen after downloading. Now coming to the first data processing technique is a cleaning. So I have basically two techniques of cleaning. If you see first method cleaning, you will see that in punctuation there are some punctuation, or we can say additional word from the keyword like semi-comma, comma, apostrophes, question mark, at the rate, hash, dollar, percentage, and actually these are the words which are not having any meaning in your given database. They are just consuming memory, and it is just waste of memory, I can say. If I take one sentence, in my structure sentence, hello, he said and went. You will find that there are three exclamation mark, then comma, then there are three dots, and there is finally one more dot. In this particular sentence, we have hello, he said, and went is only text. Rest of the part is just human understanding. Machine is not having any concern with this exclamation mark or dot or full stop. So this is we have to remove. You have to clean this particular data. One string, no punctuation, and you, with the help of this for loop, I'm just go on adding the text only, and finally I will get clean text. But this was the traditional method with the help of for loop. In Python, we are having one regex expression, RE, that you can import, and you can use this regex expression to remove this particular extra words. So if you see this program, both program, uh, only 3 lines are required for second program, and most of the 6 to 7 lines are required for upper program. So this was the traditional method using for loop, and this was using regex expression. You can remove your unnecessary word as well. Not word exactly, unnecessary information, which is just consuming memory. If I see the sentence, there are almost 6, 7, 8 extra uh, uh, keys. But if I have big data with us, that data can be in terms of 1 TB or 10 TB. So definitely in that one, it is a huge one. Extra letters are huge one, and that will going to store, or that will consume your memory unnecessary. So we'll see that afterward in programming like Jupyter. Then is a tokenization. So basically tokenization is to divide your given paragraph into sentence, and then given sentence into a word. We call this process as a tokenization. So here we are going to import two libraries, sent underscore tokenize and word underscore tokenize, for sentence tokenization and for word tokenization. So I have example with me. Hello, Mr. Praveen. How are you doing today? Question mark. The weather in Lonavala is rainy. Full stop. The sky is full of cloud. This is one paragraph. So with the help of sent underscore tokenize, I have to tokenize sentence separately. And with the help of word underscore tokenize, I have to separate words in a given sentence separately. So if I see at the bottom example, you can see here after every sentence there is a comma. So how are you doing today? We have comma. The Lonavala is rainy, comma, and full of cloud is again last sentence. But if you see at the bottom, hello, comma, Mr. comma, Praveen comma, how comma, are comma, you comma. So we have made separate word. Why we require this type of tokenization? Because we have to remove ambiguity in a given sentence. I have to separate out the word. So this will help you to remove ambiguity. Next is a POS tagging. After tokenization, it's a job. It's your job to tokenize it. Sorry, give a POS tagging to each sentence, whether it belongs to which category. So again, we are using one POS tag under NLTK library. So suppose I have one sentence, seashells on the seashore, and we have to use that function dot split. Will split the sentence in a separate sentence, and then you are going to use POS underscore tag, which is imported in NLTK library to the text, and you will get tokenization, sorry, tagging of your each word. So you will see that at the bottom, after splitting, you get seashore on the seashore separately, and after tokenization or POS tagging, you'll find that C is having tag of preposition, cell is having tag of VBZ, yani verb, past tense. Then seashells is a noun. Then on is in, the is determiner, and seashore is a singular noun, which already we have discussed in this particular diagram. So this will be the process of giving tags to every word. This is actually part of your process ambiguity. Then is uh, we can call the parsing. What do you call it? The chunking as well. You have to parse your given sentence into different layer. You have to give priority or hierarchy to the word. So let us use one sentence: learn PHP from Guru 99 and make study easy. That was one sentence, and you have to split that particular one as a first step. Then you have to give POS tagging to each word, and then afterward you have to chunk or you have to parse it. But before parsing, you should give pattern of that parsing, and that pattern is given over here, and that was printed like this. So if you see the steps, it was first splitted, then you have given POS tagging to it, and then it is passed. So actually it is in sentence and it is in diagram form. With the help of NLTK, you can plot it also, hierarchy of the word. The same thing can be happen with another text that we have already discussed. I made her duck. If I see the uh, splitting, then tokenization, tagging, you will get this string, or we'll get this hierarchy chunk like this in a diagram as well as in text form. Now, coming to the another sentence, seashore on the seashore. Again, same example. And if you see the parsing or chunking of this particular sentence, you will find that it was the same. Here is a see prepositional, cell verb, seashore noun, on, in, the DT, and seashore is a noun. These are the same parsing you are getting from the same code. Now, coming to the next, I think that was same example I have. Okay. Now coming to the next part, that was a stop word removal. Basically, in English dictionary, there are so many stop words. If I see in a given sentence, I, me, my, myself, we, both, only, are, we have, can't, would, that is not having any meaning, dictionary meaning as such, and they are just supporting word, I can say. So again, these are also extra words which are going to consume a memory of your storage. So you can remove this particular stop words. So every language is having its own dictionary of stop word. So I have shown here a dictionary of English stop words by just importing one uh, 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 file, that is corpus stop words. So by using this command stop word dots words, using I'm using this English stop, and I just print this stop word dictionary. It is like this. You can add some words as well as per your requirement, or you can remove as well from this dictionary. That provision is also available. Now it's important to remove your stop words. If I see one example, this is the sample sentence showing off the stop word filtration. That was one example given to you. So I want to remove the stop words. So in this particular sentence, this is then of, the, these are the some words which are actually part of stop word. So with the help of this first step, that is word tokenizer, I'm going to separate out the words from the given sentences, and then I'm going to work on each word. I'll just see whether this word is part of stop word dictionary. If it is, I have to remove it, or otherwise I have to leave it, keep it as it is. But the problem with this sentence is that few of the letters are uppercase and few of the letters are lowercase. So to avoid any confusion, I have just made it all word to be lower, so that there will not be any problem while giving you output. And here is that filter sentence array, which is empty right now. So after moving this forward for loop, you are going to append your sentence, and finally you are going to print this word and then a filter word. We'll see that in Jupyter as well. Then very important is stemming. So basically you should use the stem word, base word or root word to avoid any ambiguity. Let us take one example. I have one word playing. So playing is actually a combination of play and ing. So basic word of this is a play, and ing is a supporting or we can say tense one, or it is a multiple or plural one. And if I stem it, I will get one word play. I have males, so actually it is a combination of male and s. So we'll get a word male. If I remove s and if I remove ing from this word, so this is what is stemming. But there is a problem with stemming. Suppose I have one word ringing, so it is actually combination of r plus ing, and with the same rule, if I remove ing, what left is only r, and r is not having any meaning as such. So this was the drawback of the stemming. So we are shifting to the lemmatization afterward that we'll discuss. So let us complete this stemming process. So I'm using Potter's stemmer. That was a library used from NLTK tokenizer, and that will remove ings and s which are connected to the given word. So for example, I have one word. There are several types of stemming algorithms. So we'll see that here is the types. So S is extra, stemming is a ing is extra, algorithms S is extra. So you can see in the output this S ings are removed and you get the output. But you see that here it's a several. Several is a sever, which is not a correct word. Stemming is a stem, algorithms algorithm. So sometimes it gives you correct output or sometimes it is giving you a wrong output, which is not actually correct for us. So basically stemming is having some drawback, and these drawbacks are actually covered in a next part, that is a lemmatization. Here you will get a dictionary form of the word. If I use same sentence, there are several cities in mice. Uh, uh, you will see that cities is a basic form of city. Mice is a past tense of mouse. Okay, so if I pass it through the tokenization, then lemmatization process, you will find that the output is there are several city. Your cities is converted into city, and mice is converted into mouse, because mice is a past tense and present tense is a mouse. Okay. So lemmatization is a correct process which will use to give you correct output. That we'll see in again Jupyter once again. Then is a one complete example I have with me that I will explain in Jupyter complete example. I have followed all those steps. I have one CSV file of one division attendance sheet that was read first, and then with the help of all the process like cleaning, tokenization, stopword removal, lemmatization, you will get clean output. So you can see here output. This was the input file, first top 10 entries of the file, and you will see that there are some extra words, space, uh, tense are changed, and you will see that in output you will get the correct output. Few steps like stemming, then tokenization, then cleaning, all these things are applied over here, and here you will get your clean output that can be directly used by a machine learning algorithm. I'll show it in Jupyter Notebook. So this was a CSV file. Here is a cleaning. You can see that TEIT 11 studying mice in Mahajaning, that was a clean word. जो explanatory mark है यहाँ पे इस sentence में उसको निकाल के दिया है. Then is a tokenization. You will see that here is a tokenization. The TEIT studying mice in and Mahajaning, that was a separate out in tokenization. Then is a stop word removal. You can see here in is a stop word, so that is removed. In is not present in this particular sentence. And Lastly, it is a stemming. So you will see that it's a Mahajan. Instead of Mahajaning, you will get Mahajan. That was a stem word. And it's a lammatization. Mouse, you can see here, mice is converted into mouse. It's after lammatization. Okay, so after finishing so many parts of the text cleaning or data cleaning, you can now go for any application. So I have one application that I should show you as a natural language processing. One application is a chatbot and second one is a one language translator. But before going to this particular application, let us complete this uh, process of data cleaning. So here is the first uh, uh, part of data cleaning. So these are the some extra words, okay, and I have to remove these words from this particular sentence. So if I run this particular one, I will find that you'll get output hello, he said, and went. So all the expletive mark, dot dots, and full stops are removed from the given sentence. But this was a traditional method. So I have one regex expression which is used to remove that extra commas, exclamation mark. If I run it again, you will find that hello, you said, and went. You will get same output. Okay, so this was a first one is a traditional method with the help of for loop, but we have actually regex expression or regex function with us. Why not to use this one to get clean data? Now coming to the tokenization, so I have this paragraph with me. In this paragraph, there are three sentences. So I should go first, sentence tokenization first, and then is a word tokenization. So if I run this code, I will get sentence tokenization. Okay. So here you can see, hello Praveen, how are you doing today? That was the first sentence. The weather in Lonavala is rainy is the second sentence, and the sky is full of cloud is the third sentence. And that was separated by a comma. Then we want to print the word tokenization, and here is the output. We will see that hello is a separated, Mr. is a separated, Praveen is a separated, and so on. Every word from the given sentence is a separated. Now coming to the POS tagging, if you want to remove ambiguity from the given uh, 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 sentence, you have to tag it. Okay, so I have one sentence, seashell on the seashore. That was the one example. I have to tag it. Okay, so I have to first split it. So this was the splitting of the given sentence. C को separate किया है, cell को separate किया है, and every word is separate out. Okay, now it's a time to give a tag. So with the help of POS tag underscore POS underscore tag text, you will get output like this. So you can see here C is given tag of preposition, cell is given tag of verb, seashell is given tag of NN, IN, DT, and NN. This was a what we call as a POS tagging, part of speech tagging. This process is required to remove or avoid ambiguity in a given sentence. Now, coming to the next part, that was uh, I have one sentence: learn PHP from Guru 99 and make study easy. So let us see what is the output of this. Here is a separate sentence, and here the tagging. This will be the output like this. Okay, you can show it graphically as well. So if I want to show this graphically, I should give pattern. Okay, and it will be looking like this. Okay. So here it is chunk, it is NN, and if I see output, it will be like this. Here is a chunk in word, and here is the graph of your chunk. So parsing in short, we can say. Okay, so same is a written word and it is in a diagram form. Okay, now coming to the next example, I made her duck. Let us see what happened with this. So here is that output of I made her duck. I is a preposition, made is a verb, her is a preposition, and duck is a noun. It was the output coming from the code. Now coming to the another example, seashells, seashore on the seashore that we already discussed. See, so here is that output of given a sentence in a chunk form or parsing one with the help of NLTK. Now coming to the stop words, as I told you, we have a dictionary. Here it is language use is English. You can change it, make it Marathi, Hindi, English, Urdu, Japanese, German, and so on. And here is a dictionary of your stop words. So these are the words you can remove from your given paragraph. So basically, you can add some words or you can remove some words as well as per your application. And here is a small program to remove the stop word. So here is the one example. The sentence is given to you like this. And here are some extra words or stop words. We have to remove it. So let us run it. Here we'll say that in first step, it was separated out. What do we call the tokenization? Okay, and after tokenization, you have gone through the stop word removal. So you can see here is not present over here. A is not present over here. Then stop is not present over here. Off is not present over here. The is not present over here. Okay, rest of the parts words are available in a output after stop word removal. Now coming to the just wait. Okay, now coming to the stemming operation. Stemming is just a process of removing extra words like ing, ed, s, and so on. So I have one sentence. There are several types of stemming algorithms, and the output will be like this. So this was after tokenization output. Words are separated, and on every word, the stemming operation is performed. There are several. Else is removed. टाइप्स का एस निकाल दिया है, स्टेमिंग का ing निकाल दिया है और algorithms का s निकाल दिया है. But as we explained already, there is a drawback of this particular stemming operation. It is not true all the time to remove ing, ed, s. So we have to go for lemmatization. Lemmatization is a process of getting the stem word or root word, I can say. So I have an example. There are several cities with mice. That was one sentence. So you can see here, cities is actually past tense of city and mice is a past tense of mouse. So if I run this, I'll see that get this output. There are several cities with mice. That was after tokenization, and after lemmatization, here is the output. So we'll see that city. The city is a root word and cities is a plurals of the city. And here is a mouse is a root word and mice is a past tense of a mouse. So here we will get correct stem word so that you can avoid ambiguity, meaning of the word. Okay. So here is that complete example. I have one CSV file which includes one database, and I have applied all the operation like cleaning, tokenization, stop word removal, lemmatization, and then get the output. Let me show you that. This was the first output. This was the CSV file contents, and after operations, this was the first output we have after cleaning. This is what after tokenization Then we have lemmatization process and so on. Here you will get example Mahajan. Instead of Mahajaning, ing निकाल के जन लिख के दिया है, and so on. Okay. Okay. Now coming to our application. We have first application is a chatbot. So basically, chatbot is a smart application that reduces human work. So all the time it is not okay to serve by human to the customer. The customer may get primary information about the company, about the organization by just typing some word, some questions, and your bot will automatically answer it. Nowadays, you can see this type of chatbots on the right side bottom on of the any organization. Maybe it may be school organization, it may be college organization, or it may be bank. So chatbot is always available at the right side of the bottom. So let us try to build this chatbot, but let us understand what about the chatbot. So basically there are two types of chatbot. One is rule-based and second one is a self-learning chatbot. In rule-based chatbot, the question answers are fixed. If the question is asked, the answer is common, or it is a fixed answer has to be given. So for example, if I ask what is the name of your college, so answer is fixed. The name of my college is Srinagar Institute of Technology. That will be the fixed answer. So some rules are placed, and according to the machine learning model, it will run your chatbot. But in case of self-learning chatbot, it will be going to answer you some technical or typical questions, which is not part of your rule. Some extraordinary questions also can be answered. So on the backend, you should use internet to search your given data. If the question is related to weather, so if I ask what is the weather tomorrow in Lonavala, so I should take help of internet, and after taking help, I can goes to the APIs which will tell me about the weather, and that is it. That too in Lonavala, not in Pune, not in Mumbai. So that was the typical information asked by customer. So your self-learning bot will answer such type of questions by learning method. So first of all, we'll try to build our GUI. But before that, just listen carefully. One more application I have implemented over here, and that was the text-to-speech application. So you can see here, there is some text written over here in a paragraph form. So with the help of GTT, you can convert that text into speech. So let's listen this speech carefully. If it is not audible, just tell me. I'm going to start it.
We will design a simple GUI using the Python TK intermodule, using which we will create a text box and button to submit user intent. And on the action, we will build a function where we will match the user intent and respond to him on his intent. If you do not have the TK intermodule, then first install it using the pip command.
Hope you have listened this text speech, which your machine learns. Basically, on the backend, GTT is a Google text-to-speech converter is used. That was simple command, which will convert given text into a speech. So this is used to read any book as well. Nowadays, in a smart mobile, right now, this feature is also available. You can read what is pop up on your screen by pressing that chatbot. He will read all the contents of your either Google, either it WhatsApp, or either in Facebook. जो भी content आपके सामने आते हैं, your machine or mobile will read it. You will get audio experience. If you are not or you are bored with reading contents, you can just listen it. This was one example of text to speech. Okay, so let us continue this point. We have to build a GUI using Python, and for that purpose I need to use TK Enter. So basically that was TK Enter is one module which will help you to create your GUI. Okay, so if it is not available, you have to install it with simple command pip install TK Enter. Here is that complete code of a chatbot, and this is a particularly rule-based chatbot. So it will start with by importing star from the TK Enter, and here is a root TK, and you have given title to this particular GUI is a chatbot. We have specified one function. We have defined one function send, which is basically hide under a button, and it will play this complete code. Okay, so what will happen here? If you see, if you type any question and send it, it will use to match this particular sentence with given rule. For example, if user enters hello, your bot will reply hi. If user enters either hi or hi or hi, then your bot will reply hello. If your bot or user enters how are you, your bot will reply fine and you. If user enter fine, I'm good, or I'm good, doing good, so your bot will reply great, how can I help you. But if other than these four questions, if any question asked, your bot will answer sorry, I didn't got you. That will be the possible answer. The solution is that you can increase this number of question answering in this particular function. And here is the grid, how many rows, how many columns, what is width, what is height of this particular GUI. And here is that send button created. Under that, we are going to call this send function. Okay, and here is that complete screen of a chatbot. You can see send button is located on the right side, and on this empty part you can write your particular questions, and your bot will answer you. Okay, so let us see this example. Okay, so this was that code I have with me, and questions are again same, so I'll just run it. Okay, we'll see that this particular GUI is created as per our choice. What will the height, what will the width, what is the location of send, and everything. So thing is that I have to give some question to the chatbot. Here is a title, chatbot. Okay, so if I write something, it will be going to answer me as per question query. So let us type hi over here, and I'll send it. Okay, so the bot will answer hello. Okay, instead of hi, if I say hi I, still you will get answer to be hello, because in our else loop I have given that choice. What should be the type of hi? I will ask one more question. How are you? That's actually part of our questionnaire. So your bot will answer how are you, fine, and you. So to reply this, I will ask one more question. User will enter, let us say fine. Okay, this is also a part of our questionnaire, fine. So your bot will reply you, great, how can I help you? Now these are the questions from our rule. But if I ask other questions, let us say I ask what is your name? Okay, that was a general question, which is not part of our questionnaire. So definitely he is not able to answer this particular questions. So here he will answer, sorry, I didn't got you. And I think you have experienced this same thing in a banking chatbot. There are some fixed questions your chatbot will answer you. If you ask other questions, he will ask to repeat it, or he will ask to ask something else. Okay, this was a small chatbot, a simple chatbot. New version, next version chatbots are also available, which are using machine learning algorithm. They learn from the questions and get the answer from the internet, maybe YouTube, maybe Google. Uh, there are some chatbots, they will play song for you, they will send mail from you, they will give information about weather, date, time, as per your mood as well. They will play songs. So this is a bots available right now as well. So it needs more programming and understanding of this language. Okay. Next, I have one more application, is a language translator. So basically, this is a language translator. You have to give input in the form of text, and you can get output in the form of text and video, audio as well. Okay. So language translator is a very actually crucial job, because if you enter any text, it has to understood. Understood means every word is having different meanings. Sometimes it is one meaning, sometimes it is two meaning, and so on. Whether it is used single, whether it is used in a sentence, that is also going to matter, which we have discussed already. For example, duck. Duck is used single, that become noun. But if duck is used in a sentence, it become verb. So your machine has to understand what is the meaning of this particular sentence, and then after it has to convert into a different language. So language is not having a limitation. It can be Marathi to Hindi, Marathi to English, or English to Hindi. It can be Japanese, it can be Urdu, it can be Germanese, and so on. So bank is not limited. It is, you can use any language. So here is a complete code of that translator, which is actually easy one. So I'll not go through. This was that language we are going to suppose about 107 languages are available in a drop down box, and you can convert that into again different languages as well. Okay, so here is a translate button which will translate your given text into another language, and with the help of this particular uh, file, like for example play audio, you can play your text as well, and you can listen it in an audio form as well. So both visual and audio form output are available. So for any given natural language processing application, your input can be text, input can be audio. For example, your Google Assistant is giving input. We are giving input in the form of audio. Okay. In a language translator, you can give input in the form of audio as well as in the form of text, and you can get output in the form of text as well as in the form of audio as well. And here is a GUI. You have decided what is the width, what is the length, which are the tables, buttons you are going to use, which is a, where is a drop box you have to assign, where is a play button you have to put. That you can decide. Locations you can manage. And let us try to play this particular code. So instead of Jupyter, I have one more editor with me. Ideally, there this total complete code is available. And if I play it, you'll get this language translator. Okay, so here is that drop down box where you are having almost 107 languages available in your choice. Okay, and I have set by default Marathi as a text input, but it can be any as per your choice. So what I enter here will be converted into language, and we have selected that language to be Marathi. Okay, so I'll type some input in English, let us say, and in output box I'll get that into Marathi. And here is that play button which will play a sound. So if I type here, how are you? Let us say, how are you? This was the one text you have entered, which is in English, and this is converted into Marathi. So I have one button, translate. On the back end of this button, I have one small program which will translate this English into Marathi. So actually it is very difficult to convert because I have to follow the process like parsing, remove ambiguity, and then getting the meaning, correct meaning, that too in a different language. So that was done over here. And here you will get Marathi output to kasa ahes. That was a conversion language translation. And here is that play button, which will also play your text, what you have getting output. So just listen carefully.
तू कसा आहेस?
Okay, I think hopefully you have listened this output as well. So this is one example of natural language processing you can perform. So that's all from my side. Thank you. Thank you very much. If you have any query, you can ask.
Really nice session, sir. And it's a very informative session. So,
Hello.
Himanshu ma'am, please post feedback link from attendance on chat box.
Yes, ma'am.
And
Yes, ma'am. Thank you so much, sir. Your session was very informative and very nice session, sir. Now, all the participants having discussion forum, you can discuss and ask any query from today expert. Dear participants, kindly ask any query. I think no queries. No problem. Dear participant, feedback come attendance link is shared in chat box. Kindly please fill it. Now I conclude today's session. That was indeed motivating and extremely informative. It will definitely help us to build our future. We are so honored and privileged to have you amongst us today. I would to thanks to our today resource person, Dr. Praveen Latne, sir. And
thank you, ma'am.
I would also like to extend my heartily thanks to our principal, Dr. M.S. Nokle, sir, for providing a platform and resource to organize the FDP. And I also like to thank to all the head of the department for joining there and make this program successful. And also thanks to all my dear participants for your presence and participation. So on behalf of the IT department, I would like to express my sincere thanks to all of you. Now, I conclude today's session and see you tomorrow on day 4, 29 Feb 2024. That is the Thursday. Same timing 2:30 to 4:30 p.m. Session 4 on the computer vision concept of convolutional neural network and its application. Resource person Dr. Sanjay Jain sir from ITM University, Gwalior. Thank you so much, sir.
Thank you.
Thank you, ma'am.
Welcome, ma'am. Now